Well, hey there, welcome back for another video tutorial. This is Dr. Franklin, and I will be presenting to you step-by-step procedures that you can utilize to calculate the t-test for two related samples. So in a repeated measures research study, the same sample of individuals is tested in all of the treatment conditions. This design literally repeats measurements on the same subjects. So in the given example, we have 8 subjects represented by the first 8 letters of the alphabet, and we see per subject we have 2 instances of scoring. So the treatment indicates some independent variable, and let's move that down a little bit, and we are assessing a dependent variable for changes. So we have something that is categorized as before treatment or a baseline assessment on a particular variable, and then we will look at that particular variable after treatment or some kind of intervention is put into play. So the repeated measures t-test begins by computing a difference between the first and second measurements for each subject, or the difference for each matched pair. The difference scores, or capital D scores, are obtained by doing the following. You will get these scores by subtracting x1 from x2. Before treatment is usually characterized as x1, and then after treatment is usually characterized as x2. See here that we're utilizing subscripts as a means of differentiating one instance of the variable being measured from the other instance of the variable being measured. So what you will do is, for each participant, you'll go x2 minus x1. So here we have 7 minus 8, then we have 5 minus 7, and we have 6 minus 6, then we have 6 minus 7, then we have 7 minus 9, 5 minus 8, 4 minus 5, and 4 minus 9. So if you do those out, you end up with -1, -2, 0, -1, -2, -3, -1, and -5. So moving on to the next step, the next thing you want to do is square your different scores. See how I have a d squared column, and we're going to square our different scores because ultimately we'll need to do something with our different score column as well as our squared different score column as far as inputting it into the sum of squares computational formula to allow us to get the sum of squares for differences. So difference column first step, d squared second step, so we go -1 squared, -2 squared, 0 squared, -1 squared, -2 squared, -3 squared, -1 squared, and -5 squared. So every number in this d squared column should be positive, because if you multiply positive by positive, you'll end up with a positive, and if you multiply negative by negative, you'll end up with a positive. So guys, moving forward, the next thing that you want to do is calculate your mean difference score. And your mean difference score is the sum of d over the number of individuals in your sample. And you get the sum of d, or the sum of difference scores, by adding up all of your difference scores in the column. Okay, so if we were to do sum of d, we would add -1 plus -2 plus 0 plus -1 plus -2 plus -3 plus -1 plus -5. Now, when we add all those up, we'll end up with a negative 13. And what we'll do is we'll plug that into our mean difference formula, negative 13 over 8, and that will yield us 1.63 if we round properly. So on average, the mean difference that we would expect across the dependent variable for each of these 8 participants would be 1.63. So the mean difference can be thought to be step 3. And the next step involves you calculating your sum of squares for different scores. So your sum of squares for different scores is sum of d squared minus sum of d squared, and we have n in the denominator there. So in order to get sum of d squared, we will need to go to our d squared column and simply add up all of those digits. So that means we would go 1 plus 4 plus 0 plus 1 plus 4 plus 9 plus 1 plus 25. And when you do that out, you will end up with 45. So taking the sum of d squares back over here to our sum of squares for the different scores, we would plug it into the sum of d squares listed. So we would have 45 right here minus negative 13. We have to square that negative 13 over 8. Now when we do that out, we end up with 45 minus 169 over 8. And then when we do 169 divided by 8, we end up with 21.13. We have to take that from 45. And when we subtract 21.13 from 45, we end up with the sum of squared difference score of 23.87. So, difference scores is step 1, d squared is step 2, mean difference step 3. Step 4 is the sum of squared difference scores, but keep in mind that in order to do this computational formula, you have to calculate the sum of d squared first, which requires you to go back here and add up all of the digits that fall under that column header. So we're running out of space here, folks, and thus I'm going to have to delete some of the things that I wrote before starting this video. So I will go back to this column and make some space here. And with that, let's proceed with the next step. The next step, I would say, would be to calculate your variance. So you all recall the formula for variance. It is sum of squares over n minus 1. Since we just calculated our sum of squares for the different scores in step 4, we can simply bring that 23.87 up and put it in the numerator, and our denominator would go 8 minus 1. So we do 8 minus 1 out, which would give us 7, and over top that would be 23.87, and then when we complete that equation, we will end up with a 3.41 for our variance. So this can be viewed as step 5, and then from there you can proceed to step 6, which is to calculate our standard error of the mean difference. That formula is s squared over n, and we have to take the square root of all of it. So we'll drag step 5 down into the numerator here, 3.41 over 8. We're going to take the square root of everything. And once we do that fraction out, we end up with 0.43. We still need to take the square root of it. And finally, when we take the square root of 0.43, we end up with 0.66. This is our standard error of the mean difference. Now we are finally at the end, and we are going to calculate the t for this t-related samples design. The statistic for this particular test is mean difference over standard error of the mean difference. So we will take 1.63, which is our mean difference on average. That was just redundant there. It's the mean difference across the dependent variable as it pertains to the participants over the standard error mean difference, which is 0.66. When we divide 1.63 by 0.66, we end up with 2.47 as our calculated t. So this is the calculated t that we will use as a means of comparing it to our t critical to determine if there is a significant difference across the dependent variable as it relates to treatment. Okay, so now's the point where we determine if we should reject or accept the null hypothesis, and that in turn will determine what type of decision we make with our research hypothesis. Just so that I can have a little bit of space, I'm going to erase step 4, which is dealing with the sum of squares for different scores. And let's say we were told that we need to run a test with the alpha level of 0.05. It's two-tailed, and we'll ultimately need to utilize our degree of freedom to find our t critical. So with that being said, let's navigate to our t distribution table. Now we are going to go with a two-tailed test, which means that we're open to significant differences of one instance of the dependent variable being on the high end or the low end in terms of the average. And we're going with an alpha level of 0.05, which means that there is a 5% probability that the null hypothesis is correct if it indeed falls in that particular critical region boundary. And our degree of freedom is 7 for this study because we have 8 participants. And when we take 8 and subtract 1 from it, we end up with 7. Now be very careful to not assume that your degree of freedom is 15 in this particular case, because we have 16 scores. Remember, there are 2 scores per participant, and ultimately we're only working with 8 individuals. We're just assessing them repeatedly. So when we go with the alpha level of 0.05, and it's a two-tailed test, and we go down to the degree of freedom of 7, and we go where the degree of freedom and the alpha level and two-tailed intersect, we find out that our t critical is indeed plus or minus 2.365. So now that we have that information, let's go back to our whiteboard. Plus or minus 2.365 is our t critical. If we were to set up a little visual aid and say, all right, this is plus 2.365 on the high end, this is minus 2.365 on the low end. And if we were to apply this 2.47 to this curve as if it was a number line, we would find that 2.47 comes after positive 2.365. So 2.47 would likely fall right here. And given that it would fall in the region of rejection as far as the null hypothesis, then we will, in terms of our null, reject it. And that means, as far as our research hypothesis, we would accept it. In other words, this treatment is making a significant impact on the dependent variable. It wasn't specified what the treatment was. It could be medication, it could be healthier diet, it could be tutoring sessions, it could be study skills, time management, and any other types of dependent variables that are associated with those things respectively could be connected to the study. But at any rate, we're seeing that we have a significant difference here. The treatment is having an impact. So, repeated measures research studies, again, involve one sample of individuals tested in all of the treatment conditions. A repeated measures design may be preferred to an independent measure study when one wants to observe changes in behavior in the same subjects, as in learning or developmental studies. An important advantage of the repeated measures design is that it removes or reduces individual differences, which in turn lowers sample variability and tends to increase the chances for obtaining a significant result. Additionally, in a matched subjects design, the individuals in one sample are matched one-to-one with individuals in another sample, and the matching is based on a variable or variables that are relevant to the study. So the matched subjects design has elements of an independent measure study and a repeated measure study, and is intended to produce the advantages of both designs without the disadvantages. So, I hope that this tutorial was helpful. Please let me know in the comments below if you found it helpful, and if you're interested in receiving some guidance and instruction on other types of content. Affirm all as well. Take care.